this is Ms. Norman, and today we're going to be looking at parallel and perpendicular equations. So first, we're just going to remind ourselves what parallel and perpendicular lines are. So parallel lines have the same slope. So here, I have a line that has a slope of 2, up 2 over 1, m equals 2. If I wanted to have a parallel line to that, it would have the same slope. It would have m equals 2, up 2 over 1, up 2 over 1. So parallel lines have the same slope. Perpendicular lines, though, go the other way. So if I have a line with a slope of 2, a perpendicular line is going to have a slope that's down 1 over 2. So that's negative 1 over 2. So these have the opposite slope. Now, a way to get an opposite is we have to flip and switch. We've got to flip the fractions. So the number that's on top goes to the bottom. The number that's on bottom goes to the top. And we have to flip the signs. Positive becomes negative, and negative becomes positive. So let's look at how we're going to write an equation. First, we have to determine the slope of the new line. We're going to keep it if it's parallel. So these keep slope. Or we're going to change it if it's perpendicular. See how these have different slopes. Then we're going to choose a point of the new line. Sometimes they'll give you multiples. Sometimes you only have one to choose from. And then since we have a point and a slope, we're going to plug into point-slope form. A point-slope form was our y minus y1 equals mx minus x1. Then we can't graph it the way it is, so we want to get it into y-intercept form. So we're going to distribute m and move y1. So let's take a look at an example. We want to write the equation of a line that is parallel to y equals negative 2x plus 5 that goes through the point negative 1, 4. So our keywords here are parallel, our equation, and our point. So our original slope can be found in this line. This is y equals mx plus b, and our m is our slope. So original slope is negative 2. And it's parallel. That means we're going to keep the slope. So the new slope is, again, negative 2. It says it goes through this point, so that is our point, and it is our x1 and y1 in our formula. Then we just plug it in. Y minus y1, which is 4, equals m, negative 2. Remember, slope is our m. And then x minus x1, which is negative 1. Now, we have minus and negative. I can just change that into a positive. And then we just need to solve this for y. So we're going to distribute. Negative 2 times x is negative 2x. Negative 2 times 1 is negative 2. Equals y minus 4. Then the opposite of minus 4, because I want to move my y1, is plus 4. Y equals negative 2x, then negative 2 plus 4 is positive 2. That is my answer. Take another look where they don't tell us the equation of the first line. So here we want to write the equation of a line that is parallel to the line represented by the given table that goes through 8, 12. So we know our point, but we don't know the original slope. All we know is that it's on the table. So we have to find that slope by doing y2 minus y1 over x2 minus x1. These are my x's, these are my y's, these are my first point, this is my second. So I'm going to plug this into my equation, 7 minus 6 over 12 minus 8. That equals 1. 12 minus 4 is 12 minus 8 is 4, and that is my original slope. Now I need to look back. This is parallel, so I am going to keep it, so it's also my new slope. I'm going to plug these into the equation. Y minus y1, which is 12, equals 1/4 x minus 8, 1/4 times x, 1/4 x, 1/4 times negative 8. It's the same as negative 8 divided by 4, which is negative 2. And now we're going to move y, doing the opposite of minus 12, which is plus 12. Let's cancel out to give us y equals 1/4 x, and this is plus 10. To get it into y-intercept form, we are done. Let's take a look at two more examples. Write the equation of the line that crosses the x-axis at 17 and is perpendicular to the line y equals 2/3 x plus 5. So we have our original line. We know what our original slope is because it's right here, 2/3. Our new line is going to be perpendicular, so we are going to change the slope. This was 2/3, so we're going to flip it to be 3/2, and this was positive, so we're going to switch this to negative 3. And then it doesn't have a point, but it does say it crosses the x-axis at 17. That means our x1 is 17 and our y is 0. Okay, because this is a x-intercept. It's the opposite of our y-intercept. Then now I've got a new slope and a point. I just got to plug them in. Y minus y1 equals m x minus x1. Then I want to get it to be y equals, so I'm going to distribute. Negative 3/2x. And then negative times a negative is a positive. Then negative 3 times negative 17, that gives us 51. And 51 can't be cleanly divided by 2, so we're just going to put it over 2. Then y minus 0. Whenever we subtract a 0, the number doesn't get any smaller. So we're just going to put y equals, because we don't have to write that 0. This is going to be that equation. One more, and then you'll have a chance to try it yourself. So write an equation of a line that is perpendicular to 5x minus 2y equals 6 and goes through 5, 1. So if we're looking for the original slope, it's not here because this is not in y equals mx plus b. We've got to rearrange. So to rearrange, we've got to move 5. Let's write it again. 5x minus 2y equals 6. We subtract 5x from both sides. Get negative 2y equals negative 5x plus 6. And divide both sides by negative 2. Let's cancel out to get y equals, negative times a negative is a positive, but we cannot simplify 5 over 2. The negative 6 minus, or divided by negative 2, almost a minus, but it is a negative 3. So this is our original slope, 5 over 2. And it's perpendicular, so we are going to change it to negative 2 over 5. And then our point, it does say it is 5, 1. That's our x1, y1. Then we just plug it in. Y minus y1 equals m x minus x1. So negative 2 divided by 5 times x, negative 2/5 x, negative 2 times a negative 5. Well, negative times a negative is a positive. 2 times 5 is 10 over 5. I can rewrite that as 2. We have y minus 1. I'm going to add 1 to both sides to get our equation. Kind of ran out of space, so we'll write it over here. Y equals, these cancel out, negative 2 over 5x, and then 2 plus 1 is 3. Now I want you to take a moment to pause the video and tell me, go ahead and try to do these equations on your own. Sorry, I had that deer up there that whole time, but we can work around it. So take a moment to work through these. Okay, welcome back. Let's try this out. So we're going to look for the old slope, the new slope, and a point. So our old slope is 1 over 2. And it's perpendicular, so we're going to switch that to negative 2, because it becomes negative 2 over 1, which is the same as negative 2. Then our point is negative 4, 6, and that's our x and our y. So we're going to plug in y minus 6 equals negative 2, x minus negative 4. This turns into a plus. We distribute. Negative 2x minus 8 equals 6 subtracted from y. We add 6 to both sides to get y equals negative 2x minus 2. One more. We want something that's parallel. Our old slope is negative 3, so our new slope is also going to be negative 3. And then it's a y-intercept of 8. So we can go straight to y equals mx plus b, because I know all of these. I know my m, which is negative 3, and then my y-intercept is 8, so plus 8. And that is it.